Lesson 9.7 is translating functions. When you translate something, you're shifting it. So it might be up, down, left, right. Okay, and so first of all, we need to talk about what's called a parent function. A parent function is the basic. It's the very basic core function, and then on top of that, transformations can happen, and then the function gets more numbers in it. But a parent, think of your parent compared to your siblings. Your parents, their genes were passed down of the kids, then get the traits of the parents. And so a square root function is the first one I want to talk about. That parent function is y equals just the square root of x. That's why it's called the square root function. And I want to talk about why the graph looks like this by making a table. And usually what I like to do is make a table for x values between -2 and 2, and that gives you a pretty good idea. So if I were to take -2 and plug it in for x, I would need to do y equals square root of -2. We know that's imaginary, so that doesn't exist. So there's nothing there. Same thing for -1. I can't square root of -1. What if I square root of 0? That's just 0. What if I square root 1? That's 1. What if I square root 2? Square root of 2. What if I square root 4? That's 2. What if I square root 9? That's 3. And so what happens here is this graph does not exist when x's are negative values. But there is going to be a point at the origin, 0, 0. There is a point at 1, 1. There is a point at 4, 2. There is a point at 9, 3. So that's the way that graph goes. Okay, so let's talk about a vertical shift. A vertical shift happens when you have your function and then plus or minus a number after the function. So when I have y equals the square root of x plus 4, this on the end makes it go up 4. So I'm going to take all of these points and just move them up. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this function would now look like that. And on Delta Math, you'll click and you'll drag that up there. All right, a horizontal shift. That's when you have a number inside with x. So see how now the plus 4 is inside the square root? And it always does the opposite. Because it goes x minus the number, this must have been x minus -4. And so this, even though it's a plus, actually went left 4 units. And you'll get the hang of it. But right or left, it's always the opposite of how it appears. So this went left, so I'll take every point and go left. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So now this function would be doing this. All right, next function is quadratic. We should be familiar with this one. And I'll point out too that all these posters are up on my wall. The quadratic parent is y equals x squared, where it has 0, 0, and then if I plug in 1, 1 squared is 1. If I plug in 2, 2 squared gets me up to 4. If I plug in -1 squared, that's positive 1. If I plug in -2 and square it, that's positive 4. So it has this symmetry over the y-axis. If I have y equals x squared minus 1, this means it goes down 1. So move every point down a unit from where it was. So then it would be like this. If I have x minus 1 in parentheses, then my squared, remember it's the opposite of this, it actually went right 1. So I would move every point to the right 1. And it would be that. Okay, the next graph is an absolute value graph. It's kind of funny that an absolute value graph makes literally a V shape, because if I were to plug in -2 for x, that means I would take the absolute value of that, which would become positive 2. So at -2, there's a point at positive 2. If I plug in -1 and I take the absolute value, that puts me up 1. If I plug in 0, that's still just 0. If I plug in positive 1, the absolute value, that's 1. If I plug in 2, that's 2. So it has symmetry like the quadratic, but it comes to a sharp corner here instead of being rounded. So if I have absolute value of x minus 4, that went down 4. And if I have x minus 4 in the absolute value, it went the opposite of what it looks like, and it went right 4. So I'll let you pause it and go ahead and fix those graphs. And they would look like that. Okay, the next page, I have the cubic function, which is y equals x cubed. If I were to plug in -2 and take it to the third power, -2 times -2 is 4, times another -2 would be -8. If I take -1 to the third power, that would be -1. 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8. So you see where there's a symmetry kind of diagonally here, where it's -2, down 8, -1, down 1, 0, 0, right 1, up 1, right 2, up 8. So that's what that looks like. So you can imagine that if I have x cubed plus 3, that went up 3. And if I have x plus 3 cubed, it actually went left 3. And when I make these points, what's really happening is you'll always have these points be close together, and it kind of makes this curve feature right here and those. And there's what that horizontal shift would look like. Okay, we've got 2 more graphs to talk about. The next one is cube root. And so it's funny, it looks just like the cube function, but it's turned sideways. And so that's because we can cube root negatives. So if I had a negative, let's see, -8 is a point that I see. I can cube root -8, and that gets a -2. Because I'm saying that -2 times itself 3 times can make -8. I can also cube root -1, and that's -1. Cube rooting 0 gets me 0. Cube root of +1 is 1, and cube root of 8 is +2. So then this would be down 5. And then this would be right 5. And then the last type of function is exponential. Exponentials happen when our power is x. And real quick with a table, when I have x being -2, that's saying 2 to the -2nd power. Remember, that does not make it negative. That flips 2 and sinks it to the bottom to be 1/2 to the +2nd, which is 1/4. So as I keep getting smaller x values, all it's doing is making a smaller fraction or decimal. Even if I took -2 to the -100th power, that still won't make it, hold on. +2 to the -100th power. That times e to the -31st power makes that decimal move to the left 31 spaces. So that's a whole lot of zeros there. That just means it's a really, really small number, but it never becomes negative. And so this is what a table would look like of an exponential function, because 2 to the -1st power is just going to be 1/2, which is 0.5. If I plug in 0, anything to the 0 power is 1. If I plug in 1 as a power, that's 2 to the 1st power, that's 2. 2 to the 2nd power would be 2 squared, that's 4. 2 to the 3rd power would be 8. And so it gets exponentially big really fast. It goes bigger and bigger and bigger. But it has this asymptote here on the x-axis. That's why they have a little point right there. And so on this function, you only have to worry about vertical shifts, and this would go up 2. And so it's like I'm taking this asymptote here and moving it up 2 spots. So then my point would be, I don't want that point there, but that's okay. My point would be up 2, up 2, up 2. And so now it would hover along my asymptote and then go up. There we go. So we will never have horizontal shifts with exponential functions.